Hey everyone, today we are going to solve the LeetCode question jump game 2. Okay, so let me explain with this example 23114. So we have to find a minimum number of jumps to reach the last index, and this question guarantees that we can definitely reach the last index, and we start from index 0. So in this case, max jump is 2, so we have two choices, jump to index 1 or index 2. But the problem is we don't know whether we should jump to index 1 or index 2, right? So let's think about the next possible position. I mean, index 1 to index 2. So from index 1, we can reach index 2 or index 3 or index 4, right? And from index 2, there is only one way, jump to index 3. And where is the farthest position? So this arrow, right? So that means this arrow is created from index 1. So point is, so previous farthest position, I mean index 2. So from index 0, farthest position is index 2, right? So previous farthest position is not always creating next farthest position because as you can see, um, next farthest position coming from index 1, right? So this arrow, this jump. So that's why every time we have to check all position between, let's say, near position and the far position. So, and then find the farthest position every time. Okay, so let me explain from the beginning. We have three variables. One is a near position, initialized with 0, and the other is far position, initialized with 0, and the last variable should be jump time and initialized with 0. And then first of all, we start from index 0 and the range only index 0, right? And let's say current position is I. And we will try to find the farthest position from current position. So farthest and initialize with 0. And current farthest should be 0, index 0 plus 2, right? So 0 versus 2, and 2 is the farthest, right? So index 2. And then finish iteration between this range. So before we move next, so it's time to update near position, far position, jump position. And the near position is, so current near position is here and the far position is here. And this question guarantees that we can reach the goal, right? So that's why at least we have to move once from current range, right? So most left position of current position is far position, so this number. So that's why next near position should be far position plus 1. So 0 plus 1 is 1, right? So next near position should be index 1. And how about the next far position? So just update the far position with farthest, so index 2, right? So that's why next range should be from index 1 to index 2. And of course, before we move iteration, add plus 1 to jump. So let's move index 1. And then every time we reset the farthest position to 0. And then from index 1, farthest position should be 1 plus 3 and 4, right? So 0 versus 4. So farthest position should be index 4, right? And then move next. So index 2. So farthest position should be 2 plus 1 and 3. But we already found index 4. So that's why we don't update the farthest position. And then we finish iteration between this range. So it's time to update near far jump. So next near position should be, as I told you, we have to move forward, right? So that's why most right position of current range should be far position. So index 2 plus 1. So that's why near position is 3. So next near position is 3. And then next far position should be current farthest, index 4. So that's why next time we will check from index 3 to index 4. And then before we move forward, we should add +1 to jump. And then next, but so loop condition should be far position is less than last index. In this case, index 4 is the last position, right? 0, 1, 2, 3, 4. And current far position is index 4. That's why we already reached the goal, right? Reached the last index. So that's why we finish iteration, and all we have to do is just return current jump times. So in this case, 2. So looks good. And of course, if we have number after 4 like this, so we will do the same process from index 3. Max jump should be like 3 plus 1 and 4. And from index 4, max jump should be 4 plus 4 and 8, right? So that's why, I mean, not max jump, farthest position should be 4 plus 4. So that's why in this case, farthest position should be like 8, something like that. Yeah, so that is a basic idea to solve this question. So let's jump into the code. Okay, so let's write the code. First of all, create a near equal far equal jumps. So initialize with 0. And then start iteration. So while, so as I told you, condition should be far is less than last index. So nums minus 1. In the case, so first of all, farthest is 0. And then check farthest position from current range. So for I in range and near to far plus 1, right? And then farthest should be max and current farthest versus current position plus max jump nums I. And then after that, update near should be current far plus 1, right? And then far should be farthest. And then add +1 to jump times. So plus equal 1. And then return jumps. Yeah, so let me submit it. Yeah, looks good. And the time complexity of this solution should be order of n, where n is a number of elements in the input array. So it seems like O(n) square, right? Because we use 2 loops. But as you can see, we touch each element once with 2 loops. So that's why we use 2 loops, but we touch each element once. So that is n, right? So that's why time complexity should be order of n. And the space complexity is, I think, O1, just simple variable, use simple variable near far jumps farthest. So that's why space complexity is O1. Yeah, so that's all I have for you today. Please support me with your actions such as comment and hitting like button. I'll see you in the next question.